Hi, in this video we are going to talk about cross multiplication, which is a very useful technique that you can use when you're working with proportions or equivalent fractions. Now, we're not going to try to prove cross multiplication here. That's actually a little bit more difficult than what we need and definitely more abstract. Instead, I'm going to give you some examples so I think you'll believe that it works, and then we'll do some problems to see how cross multiplication works in practice. So let's take a look at an example that we all know is true, and that's 1/2 is equal to 2/4. Now, cross multiplication tells me that I can take the numerator of the first fraction and multiply it by the denominator of the second fraction, so in this case 1 times 4, and set that equal to the denominator of the first fraction times the numerator of the second fraction. So in this case, 2 times 2. And if I draw circles around it, it kind of makes an X, like for multiplication. So I take one side of the X, 1 times 4 is 4, and set it equal to the other side of the X, 2 times 2 is also 4. And I see that it works. It's true. 4 is equal to 4. Okay, well, let's try another example. Let's do 3/5 is equal to 6/10, which I think you probably feel comfortable with. I hope you feel comfortable with. So let's cross multiply. I take 3 times 10 on one side and set it equal to 5 times 6 on the other side. And again, if you draw the X and circle the two numbers that you're going to multiply as you go, that will help you to remember which numbers you need to multiply together and which pairs belong together. Okay. So on one side I have 3 times 10, which is 30, and on the other side I have 5 times 6, which is also 30. So again, it works. 30 is equal to 30, and this rearrangement of the numbers is valid. Now let's try an example that has larger and more difficult numbers. Let's do 11/12 is equal to 22/24. So again, when I cross multiply, I take the numerator of the first fraction, 11, times the denominator of the second fraction, 24. So 11 times 24 is equal to the denominator of the first fraction, 12, times the numerator of the second fraction, 22. And I have 11 times 24 is equal to 12 times 22. Now, in order to verify this, I have to do the math. So first I'll do 24 times 11. 1 times 24 is 24, and then 10 times 24, I'll just shift the 24 over into the next place. And when I add, I get 264. So now I'll check the other side and multiply 12 times 22, and this time I'll put the 22 on the bottom. It's always easier to have numbers like 11 or 22 with repeating digits on the bottom. So I do 2 times 12, which is 24, and then I take the other 2, which is really 20, and multiply it by 12, and I can shift the 24 over, which really makes it 240, and accounts for the fact that the 2 is in the tens place. Now when I add, I get 264, and I see that the cross multiplication was true again, because these were equivalent fractions. So 264 is equal to 264, just like 11/12 is equal to 22 out of 24. So from these three examples, I hope you see that if the fractions are equal, then cross multiplication is going to work. So now let's use cross multiplication to solve some problems. Let's try 3/7 is equal to n over 21. Okay, so we'll be trying to solve for n. Now, if we cross multiply, we can draw circles to help us remember which pairs of numbers we need to multiply. 3 times 21 goes on one side, and we set that equal to 7 times n on the other side, which we'll write as 7n. Now, 3 times 21 is 63, and we bring down the equals to 7n. So we have a simple one-step equation, and I can solve for n by dividing both sides by 7. When I divide both sides by 7, these 7's cancel, and I'm left with n is equal to 9. Now, if you remember some tricks from equivalent fractions, you might recognize that there's another way to solve this problem. If I have 3/7 is equal to some number over 21, well, I could look at my two denominators and see that the link between 7 and 21 is times 3, and therefore to find n, I could use that same link and get 3 times 3 is 9, so n is equal to 9. I get the same answer without having to use cross multiplication. Let's try another example with cross multiplication. This time I'll use slightly larger numbers. So let's take 12/18 is equal to 20 over x, and we want to solve for x. So when I cross multiply, let's draw circles to help me remember that I'm going to multiply 12 times x on one side and set that equal to 18 times 20 on the other side. Now 18 times 20 is 360, so I'll just go ahead and write that there. And now I have a one-step equation which I can solve. I divide both sides by 12, the 12's cancel, and on the other side I'm left with x is equal to 30. Now again, if you recognize some shortcuts with equivalent fractions, you could solve this problem another way. Let's take the problem again, 12/18 over equals 20 over x, and notice that 12/18 could be simplified to 2/3. So if I rewrite the equation, 2/3 is equal to 20 over x. Now I see that there's an easy link. From 2 to 20, the link is times 10, and therefore to find x, if I multiply 3 times 10, I get x is equal to 30. So by now you might be asking yourself, well, what do I need cross multiplication for if I can always use links to help me find the answer? Well, let's do an example where you wouldn't be able to use links. Let's try 5 over 9 is equal to n over 15. So first I cross multiply 5 times 15 on one side equal to 9 times n on the other side, which I write as 9n. Now I know that 5 times 15 is 75, and I bring down the 9n. And I can solve this by dividing both sides by 9. Now 9 doesn't go into 75 evenly, so I will divide that with short division out on the side. And as I divide, I see that it's a repeating decimal. So n is equal to 8.3 repeating. We had to use cross multiplication to solve this problem because between 9 and 15 there was no easy link, and furthermore 5/9 could not be simplified. If there are no easy links and the problem can't be simplified, then you must cross multiply to solve.